Which one?
Question 2.
Second question. Level 1. This one?
Yes.
Yeah. Now see this thing first. What they given now? So a beam of light source is incident normally on a plane mirror at certain distance x from the center. So let us say this is a plane mirror, and the plane mirror which is fixed like this, let us consider. And what they're saying here, a beam of light source L is incident normally on a plane mirror. So here this is, let us say this is the light source which is incidenting. How it is incidenting, they given? How the light ray is incidenting here? The light ray which is incidenting normally. Normally means normally means what? Perpendicular. Normal means what? Perpendicular. Okay.
Yes, sir.
Yes, so perpendicular. So the light ray which is incidenting on this mirror perpendicularly like this. Okay. Now when the light ray will incident now, so here then in case of a normal incidence, the light ray will retraces its path. It is coming like this, again the light ray will go like this only. Okay.
Yes, sir.
Now what they are saying here, they placed one scale, they are placed now here. So it is reflected back as a spot on a scale placed just above the light source. So here they place some, one scale is placed like this, just imagine, and it is just reflecting as a spot at this location. Okay, now what they're saying now here, now this mirror is tilted. How much angle they tilted here? When the mirror is rotated through a small angle of theta, the spot of the light is found to move at a distance y on the scale. So that means if I consider, yeah, they given this distance is given as x now. Now we have tilted this mirror, some angle we have tilted. Assume this is the clockwise, we have tilted by some angle theta. Then when I tilt the mirror by some angle theta, now here you need to understand what happened to the reflected ray. So this is the mirror now. The mirror is tilted by how much this angle of rotation here? This is theta. Now this is the initial position and this is the final position. Fine. Now as we have seen, if the mirror is rotated by some angle theta, what happened to reflected ray? How much the reflected ray will rotate?
2 theta.
2 theta. So that means earlier this is the reflected ray is falling here now. Now here the incident ray is a fixed only. Incident ray is a fixed only. The mirror is tilted. So then reflected ray rotate by 2 theta from the previous position as we have seen. and whichever direction the mirror is rotated, same direction incident reflected ray will rotate. We rotated the mirror in clockwise theta, then the reflected ray is like this now. Now the reflected ray which is like this, and how much this angle of rotation now? This is previously, this is my reflected ray now. Now this is my new reflected ray. How much this angle is at 2 theta? Understood?
Yes, sir.
Now you tell me now. They given that the reflected ray is moved how much distance they given? The spot of the light is found to be moved to the distance of y. So this distance they given y. This we can say triangle. So tell me now tan 2 theta we have taken. Tan 2 theta equal to what? Tell me now. Y by x, and 2 theta equal to y by x. And they're saying that theta is very small. Theta is very small. And if theta is very small, so remember here, if theta is very small, we can say limit theta value tends to 0. Have you studied this thing? Limit theta tends to 0, tan theta which is equal to theta.
No, sir.
Yeah, so if theta is very small, so then it is very small. We do approximate it as a, so tan theta equal to theta only. Okay. So that means we can say 2 theta, this can be approximated as 2 theta, tan 2 theta is equal to simply 2 theta. And which is equal to y by x only now. Now from this theta which is equal to what, tell me now, y by 2x. Yeah.
Yes, sir.
Done.
Sir, 1 minute.
Mm.
Done, sir.
The next one.
Sir, level 2, second one, and fifth one.
Okay. This one.
Yes, sir.
If the distance between object and its 2 times magnified virtual image produced by a curved mirror is 15 centimeters, then focal length is. So first of all, they given it as a, this image, a virtual image, and the 2 times magnified. So what type of mirror might be? What type of mirror might be? We have the magnified virtual image. What type of mirror might be?
Sir, concave.
Huh? So see, yes. Now this means, so convex mirror can form only one type of image, that is virtual diminished image. Right. Here we have magnification now. Magnified means it must be a definitely a concave mirror. Fine. So the first thing here, so we can able to eliminate these two options, we can eliminate now. And let's focus now here. This mirror is a concave mirror, first thing. Now they given it as a, and the image is virtual image. Now here if you see carefully, and if I locate my object is here, and this distance which will be taken as a u. Okay. Next, where the image has to be formed here, where the image, so here magnification, how much they given now here, which is equal to +2 given now. So basically the magnification formula, that is what you tell me now, this is minus v by u, right? So here if we observe carefully, so this object distance which is negative, isn't it? So what could be the image now here, image now? So we need to have m is a positive. The condition is this is already u value already negative. Okay. So the condition must be what we can say now, u is negative only now. That means if I place now here m value which is equal to +2, which is equal to minus of v by, that is minus u now, tell me.
Yes, sir.
So that means v will come to be a what, tell me now, from this now here 2u. Let us say this is one equation. Okay. Now they given the distance between what to what they given? Object and the image distance. Distance between object and image distance is given. That is what we can say now, v plus u. Okay, u plus v, which is equal to 15 now, tell me. Okay.
Yes, sir.
So here the image must be formed this side, isn't it? Tell me. Image, it should be formed here. So this is the image distance, na?
Yes, sir.
Yeah, so that means v plus u is given as a 15, v value to u. From this, if I place now, what I will get now? So that is 3u, which is equal to 15. That means u is equal to 5 centimeters.
Yes, sir.
Yeah, from this, what we need to do here, we need to get the, okay, if u is 5 centimeters, obviously v is equal to 10 centimeters now.
Yes.
Next, now find the focal length from this. So here, so finally, when you're substituting this thing, the formula, u is equal to -5 now. V is equal to +10, sign conventions. And focal length we need to get now.
Sir, option C.
Option C. Understood this one? Tell me how you need to approach. Any confusion?
No, sir.
So the focal length will come to be how much now? This is -10 centimeters. So this is a concave mirror now. Next one. Yeah, fifth one. This one.
Yes.
Fine. Two vertical plane mirrors A and B separated by distance of 10 centimeters. A point object O is placed at a distance of 2 centimeters from A. the distance of the second nearest image behind A from mirror A is. So what we can do here, this thing. They are asking to find what are now the distance of a second image we need to find. Second image from A. So look at now first thing here. In this type of cases, what happens now first? Here is an object now, and here we have the first image will be formed. This is the image formed by the A, first image. And this distance is how much now? This distance is 2 centimeters, right? Now this is 10, so then this distance which will be a 8. And now this is the image formed by the B mirror. So let us call this as a I1 dash. And this distance is what will be now 8 centimeters. Okay. Now,
Yes.
so here this is the first image of A and this is the first image of B now. Now what they're saying here, second image of the A we need now. Here this is the first image of B will behave like an object for the mirror A. Okay. Now you can see now here this distance. How much this distance from the mirror A to this first image of B? Hmm? How much?
Yes.
How much is distance?
18 centimeters.
18. So then corresponding 18, it will form one more image now. So somewhere will
Yes.
be formed here if I say. This is what we can say now I2. We can say now this distance. How much now here? 18 centimeters now. They are asking to find the distance of the second image behind mirror A from the mirror A. So this is second image is how much the distance from A now here? 18 centimeters. Okay.
Okay, sir.
And this is one method. So there is another way we can solve this problem by using a crisscross method. Crisscross method means, so here you can see now this is now A and this is a B. And these two mirrors separated by some distance. How much the distance is separated? 10 centimeters. Okay, so first initially at 2 centimeters now here at 2 centimeters we have first image will be formed. At 8 centimeters it will form the first image of B. Next we need to do this crisscross we used to call. And the distance between these two is at 10 now, A and B. The distance which is at 10. Now 8, so we can add 8 plus 10, which will be equal how much now? 18 centimeters. Next here 10 plus 2. This we need to add to this thing distance. So that is what will be now 12 centimeters. Next again we can continue. 12 plus, so the distance is what will be now 10 now. So we'll come it as 22 centimeters. Next this thing will continue. This is 18 plus 10, so which is equal to what will be now 28 centimeters. Like this will continue. Understand this thing?
Yes, sir.
And the next image is where you tell me now? 28 plus 10, so this is 38. And the next image is, so this is 32. Like this. And these are the images formed by, all these are the images formed by A. These are the images formed by the B. Okay.
Yes, sir.
Like this we will do it. Done?
Yes.
Yes. Any other doubts?
Sir, question 6.
Next one. A thin cylindrical rod of length 10 centimeters is placed horizontally on the principal axis of a concave mirror of focal length given. The rod is placed such a way that the midpoint of the rod is at 40 centimeters from the pole. The length of the image formed by the mirror will be x by 3 centimeters. I think this yesterday we did one similar kind of problem we did now, isn't it?
Sir, yes, sir, but I still have a few doubts.
Okay, fine. So here now consider we have take this is the concave mirror. Okay, focal length given. Focal length is given. So this is f value given as a 20 centimeters. So fine. The rod is placed in such a manner. Midpoint of the rod is at 40 centimeters. So if I consider here is a rod. If I say this is the rod. So the midpoint means here. Midpoint is O. Midpoint is at a distance of how much? 40 centimeters from the pole. And so this is this distance. And so this is the 5 centimeters now. And this is also 5 centimeters. Okay. Now we can take this point as a A and this point as a B. Now you tell me now here, this distance is how much now?
What? 35 centimeters.
Yes, that's it. Yes, so this distance is 35 centimeters. Now here this A position, we'll find the A dash position.
Okay, sir, I can do it, sir.
That's it. Exactly similar problem we did now.
Sir, I got confused by that midpoints.
Midpoint. Yes. Fine.
Yes, sir.
Next.
That's it.
Mm. Yeah, take this cloud. Wait, I'll come in a minute. Try this problem.
They're doing, sir.
Try. Can you talk about the type of the mirror?
Sir, I'm thinking it's concave.
We can't say. We have to find out in this case.
Sir, how?
Yeah, so now how we can say about concave only? May not be also. Now convex also possible.
Yes, sir.
That's why we should not conclude the type of mirror. We'll find the focal length. Based upon the focal length only, we can able to comment.
Okay, sir.
So here the focal length may be positive, may be negative. So if we got the positive, then we can say this as a convex. If it is negative, concave. Now tell me now, object distance is how much given?
And minus 25 centimeters and
Magnification is m1. Okay.
yes, sir.
So you can see now here. So if I say the first case, now if I have taken this as initial distance, case 1, yeah, if we write the V now, let us say this is V is equal to what, tell me, UF by U minus F now. Tell me now here, UF by U minus F if we write. And U value which is equal to minus 25, F value we
Yeah.
don't know. This is minus 25 minus F now. Minus common cancel it now here 25F by 25 plus F, isn't it? Let us call this is V1. Next one V2. V2 same thing, that is UF by U minus F. How much the U now here, now it is moved further away. That means 25 plus 15. It is moved away from the earlier position. So that means what happened, 40 now. So this is minus 40 into F by minus 40 minus F, which will be equal to 40 F by 40 plus F. We got the two equations now. Let's find the magnifications. Now if we have taken this as M1, M1 means, so first here we have minus of V1 by U1, which will be equal to minus 25, which will be equal to minus plus V1 by 25, and the M2, which will be equal to, we can say now V2 by 40, isn't it? Now if we have taken the ratio between these two here, M1 by M2, and it will come to be they given this as a 4 given, and that is equal to, we can say V1 by V2 into this is 40 by 25, right? So finally we have this as V1 by V2, which is equal to 10 times will get cancelled here. This is 4 tens and 5 twos, 5 fives will come to be a 5 by 2. Now I'll take the ratio between these two, V1 by V2, and which is 25 F by 25 plus F into 40 plus F by 40 F which is equal to 5 by 2. Done. Now try simplify now here. So 5, yes, now 5's now here again 5 8's 2 4. So will come to be what, tell me now, 40 plus f, which will be equal to 100 plus 4f, isn't it? 4f.
Yes, sir.
Tell me how much will come from this now. This 3f is equal to minus 60.
Yes, sir. Sir,
Yes,
F is equal to 20. I also got that. It's a concave mirror.
yes, f is equal to minus 20. So that means is the focal length is 20 and type is a concave mirror, right?
Yes, sir.
Mm. Yeah, I think this is a similar kind of problem. What they're saying here the crucial thing is its real and elongated image just touches the rod. So that means now here this is the object now exactly here the image is starting. Okay, image is starting. Hmm? Any idea?
Sir, can you explain?
Understood the problem first of all?
Yes, sir.
So exactly at this location. So here this is here the B now. So exactly image of B is starting here. So you can see now here at where I need to place my object so that image will appear at the same location. The location of the object so that image will appear at the image object and image will coincide where I need to place my object for that. Hmm? Recollect the ray diagrams where I need to place where I need to place, who tell me now, so that object and image will coincide. Huh? At the center, remembered, if we
Sir,
locate
but
uh,
how is it center of curvature, sir?
so if you locate the object at the center of curvature where the image will be formed,
Sir, but it will be same size.
it should be same size, but yeah, same size only, but inverted bhi hoga na.
Sir, but they're saying it's elongated.
So this point, you see this thing here, this is not a point image na. Look at now here this B, if we have located this thing this point, at this location, it is happening like this. You need to understand. If we say this, the B is this point, this B image exactly formed here only, na? But because of this remaining part, elongation may happen.
Okay, sir.
But A is at some other location. Look at now, B is same here. A is located here now.
Okay, sir. Understood.
Okay, so that means at the point B. So from this, can I say that B is nothing but center of curvature? Isn't it? So from this, how
Yes,
much this distance now? Tell me now. This distance which is equal to F now.
yes, sir.
This distance is 2F. Now, so this is F by 3. Can you find this distance now? A distance we can find. How much? So this is the object distance, the A object distance, A location.
I by 3F.
Yes. Yes, so this is U, which will be equal to what I can say now, 2F minus F by 3. So will be equal to 5F by 3. Since object, which will be a minus 5F by 3 now, object distance. Okay. Now from this, can you able to find the magnification for it? Sorry, image distance for this thing?
Yes, sir.
Find out now. We are talking about a point, we are talking. Image. Image distance is what you tell me now, UF by U minus F now. So this is the concave mirror only. Okay, so this is minus 5F by 3 into minus F by U value minus 5F by 3 minus F na, minus or minus plus F. F is negative now already. Simplify, get the value of B. Hmm?
Minus 5F by 2.
Minus 5F
5F
by
by
2.
2.
So this is the location of A dash location now. This is A dash location, isn't it?
Yes, sir.
Now, so what we need to do here, this object length we know F by 3. And so this is 2F. Can I able to find this one? This is nothing but image length only now. So at this location,
Yes.
this is what element of 5F by 2 now and 2.5. So this is nothing but what I can say now, F by 2. So we need the magnification. Magnification means what? Magnification, which we can say is the length of image by length of object. Length of image is what I can say now, A dash B dash by length of object is AB. So that is given as what we can say now, f by 2 by. So this is f by 3. So will come to be what, tell me now? 3 by 2. Okay.
Yes, yes.
Done now?
1 minute. Answer.
Hmm. Try this problem. Hmm. Object distance, find the image distance first. They ask you to find the volume of the object.
So D is equal to -6.
Then find the magnification.
-2.
Then what we'll do? So volume, how should be here? As I told earlier, if you remember, the Q for the Q, and so earlier the one, the length which is perpendicular to the principal axis is magnified by m times. Remember this point. And the dimension which is parallel to principal axis is magnified by m square times. Remember this point?
Yes, sir.
Yeah, so you can see now for the cube you have taken now. So when you're talking about this cube case, let's say three-dimensional like this. So here it has a three terms. Now here if we call, yeah, you tell me now this dimension which is parallel to the principal, this dimension which is this thing. Now you tell me now here. So for the cube, so here let us say one dimension is parallel to principal axis. Yes or no? And the
Yes, sir.
remaining other two dimensions, if we observe carefully how those things now here. If we say this dimension, this is the principal axis. Okay, principal axis, if I call this as a x-axis, if we call this is x-axis. Next, this is, we can call this as a y-axis. And the third one, this is my z-axis. Right. We are assuming the principal axis is x-axis. Now you tell me now how this this dimension for the principal axis, or the y and z dimension for the principal axis, parallel or perpendicular?
Perpendicular.
Perpendicular. So that means the dimension which is perpendicular to principal axis is magnified by m times. Okay, the dimension which is parallel to principal axis is magnified by m square times. M square times. So how much we got this m, you tell me here now? How much the m you got?
-2.
Yes, so that is minus 2. Yes, now you tell me now here. One dimension. If we call it about the, so if I call this as along the dimension, let us say, which is along the x direction, which is magnified by how many times? Magnified by m square times. Magnified by what, tell me? M square times. So that means it will becomes what you tell me now here. 2 square into 1 will come it as a 4. Okay. Understood what I'm saying? This is the length if I call. Next we can say now B, breadth, which is magnified by how many times you see this thing? M times only na? So it is what we can say now -2, which is into 1. So will come to be what will be now -2, and the height which is magnified by how many times? M times, that is -2 into 1, which will be equal to -2. So the volume is what, tell me now? So finally volume of image, and which will be equal to LBH na, which will be equal to 4 into 2 into 2, which will be equal to 16 na.
Yes.
This, like this we can do it. Done.
Sir, 1 minute.
And simply what we can write now here, the volume of the image, which is equal to simply volume of the image, which is equal to m power 4 times of volume of object. Okay, volume of the image, which is m power 4 times volume of object.
Sir, can you explain L again?
L. So look at now here one dimension. Yes, now look at now here how much the, this is the dimension which is parallel to principal axis. How much, how it is magnified? How it is magnified? M square times na.
Yes, sir.
So it is magnified by m square times. So that's why we call the one dimension is parallel to principal axis. So that means if I say length is parallel, length is length of the image, which is equal to what I can say now, m square times of the length of the object, I can say. Okay, the breadth of this image, which will be equal to m times of. So here breadth of the object, and height of image, which will be equal to m times the height of object. So we need the volume now from this. Volume of image will come it as what, tell me now? L into B into H. Okay, so this means which will come to be what, tell me now? So if we multiply this thing, this is m power 4 and this is L naught into B naught into H naught. This is nothing but volume of a object only na.
Yes, sir.
So here here this is, now here they given this as a all the dimensions are equal. For example, if they given unequal dimension they place now. In those cases, what we need to see here, the dimension, whichever the dimension parallel to principal axis, that dimension is multiplied by m square times. The remaining dimensions are multiplied by m times only. Okay. Done?
Yes, sir.
Hmm. And here the thing you need to remember here, the dimension which is parallel to principal axis is magnified by m square times, and perpendicular to principal axis is magnified by m times. Okay. Take this one. A very small object is placed along PA as shown in figure. Find the length of the image. So the length of this object is given very small here. If it is a length of this object is very small, and we can do so here one, if the length is a considerable, then what we should do here, we'll find this a2, we'll find this distance we know, we'll find the a dash location, b dash location. So a dash b dash is the length of image. Okay, and we need to see where this point will be located, image of this a and image of b, and the length will be taken as a dash b dash is the length of the image that we did earlier. If this object length is very small, in these cases we do the little approximation method will do, that is what we can say now, 1 by f which is equal to 1 by u plus 1 by v. Now I am differentiating both sides. Differentiating both sides. Now f is what, tell me now? F is a focal length which is constant derivative 0, and which is equal to, this is u variable. So there is 1 by u differentiation minus 1 by u square into du minus 1 by v square into dv. Okay. From this, what we can say now, dv by v square, and which is equal to minus 1 by u square into du. Got this point? Now dv means what, tell me now? Dv is nothing but length of the image. Du is the length of the object. So the dv will be equal to what we can say now here, minus of v by u whole square into du. So then that should be equal to dv, and which is equal to, and I can write this as v is a v by u is a magnification we have now, that is, which is, we can write as v by u, that is a magnification. Then we can write it as what, tell me now here, dv which is equal to minus m square into du. Okay. So sometimes if they given this is one relation. If they replace the m also, we can replace now. Where v is equal to what? Tell me now. Uf by u minus f na. If I bring to this side, so that is v by u, which is equal to f by u minus f. That I can place it as dv is equal to minus of f by u minus f whole square into du. This is the answer. If they give an answer, this also can be considered. Okay.
Okay, sir.
Yeah. Yeah, I think you can try this problem. Now this length of this object is 3 mm. That is very small value only now compared to object distance. It's a very small value. That's why directly we use the formula what we have seen now. Okay. And what the length of the image? Yes, length of the image, which is equal to what we have seen now, minus m square into length of the object, and which is equal to minus of f by u minus f whole square into du. Okay, so from this we can get the length of this image, which is equal to focal length is how much? 20. So we can put this value. So minus 20 by, this is minus 30 plus 20 whole square into 2 mm. Sorry, 3 mm. 3 mm. So this one. This in the centimeters, this will come to be in meters. Yeah, this is 3 mm. This anyway, this units will get cancelled. How much will come the length of image from this? Minus what tell me now? 400 na? 400 by 10, 100 into 3, 3 mm. So will come to be what tell me now? Minus 12 mm na? Right. Oh, 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 oh. Okay. Hmm? Completed.
Yes, sir.
Fine. Okay. Yeah, that's it. And so next class will continue the velocity problems. We'll see velocity of the image in the spherical case. Earlier we did the velocity for the plane mirrors we have seen. Next we'll do the velocity for the spherical mirrors.
Okay, sir.
Okay. Okay then. See you. Bye bye.
Thank you, sir. Bye, sir.
Bye.